When simplifying an expression that has two or more operations, like this one here, there's a particular order that we follow to ensure that we all arrive at the same answer. So here's what I mean. Someone could look at this expression 5 plus 10 times 2 and think, oh, well, maybe first I'll add the 5 and the 10 and get 15, and then multiply by 2. After that, you would get 30. But then someone else could say, well, maybe I'm going to multiply first, so you get 5 plus 20, and then you add them together to get 25. And this is a problem. We can't have one expression where you end up at two different answers. It'll turn out that this way of doing it was wrong, and this way is correct if we follow this particular order of operations. So I'll call this acronym Pemdas, but it tells us that in any type of expression, we first want to work with the parentheses, then the exponents, multiplication and division from left to right, and addition and subtraction from left to right. So going back up here, we would multiply before we would add. So let's try this order of operation in a few examples. For example 1, I'm going to write out the acronym and just make note that multiplication, division, addition, and subtraction are done from left to right as they appear. So we'll start with this here. There are no parentheses, but there is an exponent. So I want to deal with this 4 squared, which is 16. So let's write that out. This is 8 divided by 2 times 3 minus 16. Okay, next I have subtraction as well as division and multiplication. Now, this does not mean you always multiply before you divide. This means if you look at your expression and you have both division and multiplication, you would perform them in order from left to right. So first we're going to divide before we multiply. So I'm going to do 8 divided by 2 before I would multiply by this 3. So 8 divided by 2 is 4. Next, I would multiply before I subtract. So 4 times 3 is 12. And now I have 12 minus 16. I know this is going to be a negative number. 16 minus 12 is 4, and so my answer is negative 4. The thing to point out in this example is we actually divided before we multiplied, and the reason is if we encounter both of those operations, you work from left to right as they appear. Now let's try this in a different example, one that has some parentheses. So looking at this expression, I have to deal with, well, there's parentheses here, but there's only one term in it, so there's actually nothing to do. So I'm going to focus on this set of parentheses first. All right, I have 3. I have to deal with this 2 minus 3, which 2 minus 3 is negative, in fact, negative 1. I then would add 4 times negative 2. So next, I scan the expression. I see there's an exponent, so I have to deal with this negative 1 cubed. So I know since this is negative and that's odd, the answer is going to be negative, and 1 cubed is 1 times 1 times 1, which is 1. So this whole thing here is just equal to negative 1 itself. So I'll write that down. This is really just 3 times negative 1. I mean, it doesn't look like much change from here to here, but it did. Cubing this negative 1 gave us a result of negative 1. I would then add, okay, I have multiplication, which I'll do next, 4 times negative 2. So the product of a positive and negative number is negative, and 4 times 2 is 8. Okay, next I have multiplication. 3 times negative 1 is negative 3, plus a negative 8. So here I am adding 2 negative numbers. So the result is going to be negative. 3 plus 8 is 11, and so my answer is negative 11. So let's try one more here, an example 2. It's just slightly more complicated. Okay, we have negative 1/5 times negative 15 halves minus then negative 1/4 squared. So in each set of parentheses, there's only one term. They all happen to be negative, but that means I'm going to deal with this exponent first, negative 1/4 squared. Maybe I'll do a little bit of work off to the side since this one is kind of complicated. If you look at negative 1/4 squared, since we're squaring a negative, I know the answer is going to be positive, and 1/4 squared is a fourth times a fourth. And 1/4 times 1/4 is a positive 1/16. I'm going to put that back into the expression. So that is, we have negative 1/5, we have negative 15 halves, and it's minus, I don't even need parentheses, but it's minus, and we're subtracting 16. So next, I would like to multiply before I subtract. So again, I think I can do this one a little work off to the side here, but we have a product of two negative numbers. So I know the answer is going to be positive. It's going to be whatever 1/5 times 15 halves is equal to. So off to the side, that's what I'm going to write out. I know it's going to be a positive 1/5 times a positive 15 halves. So let's simplify this. Okay, you could just directly multiply across. However, I see that 5 goes into itself once and it goes into 15 3 times. And this means my answer is 3 halves. So all of this is equal to 3 halves. So we have 3 halves minus 1/16. All right, so to subtract these, I'm not really sure if the answer is going to be positive or negative. Well, I mean, I have an idea, but I need a common denominator. And my least common denominator for this problem appears to be 16. And this is because I can multiply 2 by 8 to get to this denominator. So I'm going to take this fraction and multiply it by 8 in both the numerator and denominator. So, maybe just off to the side, I'm taking 3 halves and I'm multiplying it by 8 on both the top and the bottom. Because in the denominator, 2 times 8 is 16, and in the numerator, 3 times 8 is 24. So I'll put 24/16 back into this expression. Okay, it's clear to me that, well, the answer is definitely going to be positive. The reason is the denominator of 16 does not change, and this is simply the problem 24 minus 1, which is a positive 23. I don't think there are any common factors. You could write this as a mixed number, but I think this answer is completely acceptable. So the answer to this whole expression was 23/16.